The molecular shape and electron pair geometry of XeOF4 are respectively. We need the knowledge of Vesper theory to get the answer for this type of questions. First, we will draw the Lewis structure of this molecule. Now we will count the number of valence electrons in this molecule. Xenon is a noble gas. It belongs to the group 18 in the periodic table. Therefore, xenon contains 8 valence electrons. Oxygen is a group 16 element. Therefore, oxygen contains 6 valence electrons. Fluorine is a group 17 element. Therefore, one fluorine atom contains 7 valence electrons. But there are 4 fluorine atoms in this molecule. Therefore, the total number of valence electrons in these 4 fluorine atoms are 7 times 4, that is 28 electrons. Therefore, XeOF4 molecule contains 42 valence electrons. These valence electrons exist as electron pairs. Therefore, we will calculate the number of electron pairs in this molecule. This molecule contains 21 electron pairs. These 21 electron pairs exist as bond pairs or lone pairs. Next, we need to find the center atom of the molecule. Usually, the center atom of a molecule is the least electronegative element. This molecule contains xenon, oxygen, and fluorine atoms. The least electronegative element is xenon. Therefore, the center atom of this molecule is xenon. Fluorine always forms single covalent bonds with the center atom. Therefore, we will connect these 4 fluorine atoms to the center atom using 4 single covalent bonds. Oxygen usually forms a double covalent bond with the center atom. Therefore, we will connect this oxygen atom to the center atom using a double covalent bond. Now we have assigned 6 bond pairs. Therefore, we can write 6 bond pairs. There are 21 electron pairs in this molecule and we have assigned 6 bond pairs. Therefore, the number of lone pairs is 15. Now we will assign these 15 lone pairs around these terminal atoms. Always we have to give octet to all the fluorine atoms and this oxygen atom. First we will give octet to the highest electronegative element, fluorine. We have assigned 12 lone pairs around these 4 fluorine atoms. Now we will give octet to the oxygen atom. Because of this double covalent bond, oxygen atom has 4 electrons. Therefore, we need to assign 2 lone pairs to this oxygen atom. Now we have assigned 14 lone pairs around these 5 atoms. But there are 15 lone pairs. Therefore, the remaining lone pair should be assigned to the xenon atom. The final step is assigning formal charge. First, we will calculate the formal charge around a fluorine atom. Formal charge of fluorine equals number of valence electrons, that is 7, minus number of electrons in lone pairs, that is 6, plus number of bond pairs, 1. Therefore, the formal charge of these fluorine atoms is 0. Now we will calculate the formal charge of this oxygen atom. Formal charge of this oxygen atom equals number of valence electrons, that is 6, minus number of electrons in lone pairs, 4, plus number of bond pairs, 2. Therefore, the formal charge of this oxygen atom is 0. Now we will calculate the formal charge of the center atom, xenon. Formal charge of xenon equals number of valence electrons 8 minus number of electrons in the lone pair 2 plus number of bond pairs, that is 6. Therefore, the formal charge of the xenon is 0. This is the Lewis structure of XeOF4. we will calculate the number of VSEPR units around the center atom. VSEPR units are either single covalent bonds, double covalent bonds, triple covalent bonds, or lone pairs. There are 4 single covalent bonds, 1 double covalent bond, and a lone pair around xenon. Therefore, there are 6 VSEPR units or repulsive units around the center atom. The electron pair geometry around the center atom is octahedral. Therefore, we can eliminate second, third, and fifth answers. These are the possible shapes of octahedral geometry. There are 5 atoms bonded to the center atom, and the center atom contains 1 lone pair. This molecule is AB5E type. Therefore, the shape of this molecule is square pyramidal. Answer is number 4.